Hey everyone, for today, let's go over an Amazon interview question together. Let's go through some examples to understand the interview question better. The first example has the budget equals to 4, and the prices are as follows. For this example, this area will be the biggest area you can purchase with the given budget. Let's look at the next example. It has more than one rectangle that provides the biggest area under the budget. In this case, you would just choose one and return the computed area. It would be either this area or this area. Let's move on to the third example. All of the prices are bigger than the given budget, which is equals to 1. In this case, you will simply return area equals 0. The budget for the last example is $40. Even if you add up all the prices in the array, it is smaller than the budget. In this case, you would simply return the entire area, which is 9. Before you dive into coding, make sure you ask clarifying questions. You want to make sure that the interviewer is on the same page with you. Here are some examples you can ask for this question. Is it possible to get a negative budget? The answer is no. Is it possible to have a negative price in the given grid? The answer is no. What is the area of each grid? It will be 1 for this case. Should we expect prices to be high? Integer overflow? And the answer is no. Let's break the question into two different subproblems. First one is to find an algorithm to visit every possible rectangular area within the given array. The second part is to calculate the price of rectangular areas. In order to visit every possible rectangle, I would affix the top left corner of the rectangle and expand. Something like this. When I explored all the possible rectangles starting from this top left corner, I would move my top left corner to the next element and iterate the same logic. And I will continue until my top left corner becomes this bottom right corner right here. Then for every rectangle we find, we will calculate its price and compare to find the biggest area that we can purchase with the given budget. Let's see how we can code the brute force approach. First, we create a variable to keep track of the biggest area we found so far. Then we write for loops to iterate through every possible rectangle in the given 2D array. The first two determine the top left corner of the rectangles. The next two loops determine the width and height of the rectangles. Once we get the top left corner, width, and height of a rectangle, we compute its price and compare with the biggest area found so far. The helper method to calculate the price is really straightforward as well. We just go through the defined area and add up all the prices. I hope you noticed that there are a lot of redundant price calculations happening in this brute force approach. We can improve the overall time complexity by pre-computing the prices, of course trading off with the space complexity, and improve the price calculation from order of n squared to order of 1 constant time. I would pre-compute prices of all rectangles starting from the top left corner. Then I can use this pre-computed array to find prices of any rectangular areas in constant sign. So this is the pre-computed prices of the given array above. So this would be the price of this rectangular area. This would be the price of this rectangular area. And this would be the price of this rectangular area. And this would be the price of this rectangular area. Using this array, if I want to calculate the price of, for example, this rectangular area, can do it by starting from this array, which is $10, minus this portion, which is $2, also subtracting this portion, which is $4, and lastly adding this portion, which is $1, because this portion has been subtracted twice. It's just 4 mathematical operations, so it takes only constant time to calculate the price. In this case, it will be 10 minus 2 minus 4 plus 1, so it will be 5. You can further improve your algorithm by optimizing the visiting logic. We know that prices are positive integers, so if you increase the area, we know the overall prices will go up. Prices are essentially sorted in ascending order. Using this observation, we can use some sort of binary search to reduce the number of vegetations. So instead of starting from the smallest rectangular area, you can start from the middle and decide which side to ignore by comparing with the budget. You can either choose to ignore the left side or the right side. This will essentially reduce half of the rectangles of vegetation. Let's see how we can code the optimization on price calculation. It's really similar to brute force approach we discussed earlier. We just need to have a pre-computed prices and we use that to calculate the price. Let's see how we can generate the pre-computed price. First, we create an array to hold the pre-computed prices, and we pre-compute the first row and first column separately to avoid boundary checking. When we calculate the accumulated sum for the first row, it's basically x minus 1 accumulated sum plus its current price. Similar for the first column, it's y minus 1 accumulated sum plus the current price. And the remaining computation is pretty interesting. It's basically the opposite logic of what I explained in the slide earlier. And when we go to the calculate price, it's basically the logic that I explained in the slide to calculate the price.